Hi. In the previous section, we have covered the topic thermal stresses. So it is almost cover of the first chapter, but a few example I have taken, which is a very basic example and very basic small concept is included in this example. So if you see this session, it will be a little helpful, but in the concept right, it is not that much helpful. So if you prefer to see in the continuous session, so it will help you a little bit. And I'm going to finish this session very quick as possible. So first example is taken as a simple prismatic rod, which is divided in the different segments. Just taken the rod which is shown on the PDF at left side, which is moved from the A to B, and it is subdivided into four cross section: A, B, B, C, and C, D, and D. So at different point, it is apply the different forces, and this kind of example they used to ask find out the total change in length of the cross section. They might give you sometime any in between forces which is unknown, like P force. So other forces they will give, and they will ask what is the force which will be at that value of P. If this and this is the total deformation of that rod. So in such kind of example will come on this, and if you see this kind of example, it is very easy. Uh, I have a draw that three body diagram of the different cross section in the right side of that diagram, but it is not necessary really, because if you understood the concept behind of that, you need not to draw this. You can straightforward go to the cross section, and you can find out whether it is tensional forces or the compressive forces, and what will be the magnitude of that force. So in this example, I'll move from the A to E. It's a cross section. So I've taken that at cross section at A point, the force is tensile force, and which is act it in the tensile manner at 8 Newton meter. It's on kilonewton. I take the value I have taken, which is denoted for the force, which is it is in kilonewton I have taken. So it is 8 kilonewton. So what you will do, you will first take draw the vertical line in between this A and B cross section. Now you see, you have to move in the right side of that diagram. So prefer so when you going to the subsequent cross section, you have to decide any single direction. Now in this direction, I'm going to select the forces only in the left side. So you see, this is the forces which were taking which is moving to the left hand side. I have taken as a the tensile forces. So now if you draw the cross section, so which force is acting on this cross section? It is nothing but 8 kilonewton meter. So when you draw this free body diagram of that A and B cross section, so in that condition, the tensile force is acting on it, and it is 8 kilonewton. Now we move to the second cross section, which is nothing but B to C, and if you draw a vertical line through it, so now you see that forces which is moving at the left side. What is that? It is nothing but when you apply the left side addition of the first at point A, it is 8, and next it is the right side, it is moving 4 kilonewton. If you minus 4 from the 8 kilonewton, so how much it will remain? 4 kilonewton. And where it is going to direct it, it's directed toward the left hand side. That is nothing but it also shows the tensile forces. So in the BC section, the force is nothing but 4 kilonewton, which is 8 minus 4 is equal to 4, and it is tensile direction. So now similarly we move to the next cross section, which is nothing but CTD. And in this direction, now we have come to the BC cross section, where we have seen that 4 is the for kilonewton force, and which is in the positive direction, which is nothing but the left hand direction. Now the force at the C is acting toward the right hand direction. So it is minus from the left hand direction, which is 4 minus 2, 2, which is acting toward the left hand direction. So what will be the force remain? So that shows that the force is tensile force, and which is in the positive that left hand side direction, which shows the tensile forces. So now come to the direct fourth section, which is D to E. And if you draw the vertical line, you need not to vary with respect to the entire cross section from A to D. You just simply take the force which is acting on the E direction, which is also in the tensile nature, which is going outward direction. If you calculate in a different manner as well, you will find the same answer. And if you take this in this way, you will find the same answer, which is nothing but 4 kilonewton in the tensile direction. So this is how you can find out the example. And with respect to the formula, change in length for any cross section PL divided by AE. A is nothing but the area of cross section, and A is the modulus of elasticity of that particular cross section. If it is different material, then we have to be careful with the value of E and its diameter. If it is changing, it's different diameter, then you have to apply the different diameter. Otherwise, the concept will remain same for all these kind of example. Now we move to the second example where I have taken that one simple rod is tied with a nut and bolt. So what will happen when you apply the force at this rod? So what it will do, it will try to shear that nut and bolt. It will simply slash away if the forces is more than the shear forces of that nut and bolt. So it will simply slash away, and the nut, the nut which is held by a bolt, it is getting break, and it will simply come out of that cross section with including the nut bolt cross section. So what happening here? The force when you apply the forces, it is converting to the shear forces, and in this condition, if you need to find out the shear forces, so what will be the shear force? We know the formula for the shear force is shear force divided by area. But in this condition, the shear force is taking in place of two, which is nothing but at the top of the that section and at the bottom of that section. So there is a two place where the shear is going taking place. So we have to divide this p force into two cross sections. So I have taken as a shear stress which is applied equal to p divided by 2 divided by area. Area is nothing but the diameter of that bolt, not a diameter of that rod. Similar manner, if you and this is another cross section which is shown, which is simply the cross section of the bolt, which is cut with that rod. And if this is the same fashion you can draw for uh, that rod as well. So here, this is the shear force which we are calculating. It is for the nut which is getting sheared, not for the rod. If it is the rod is getting sheared, that is nothing but that the rod is has a weaker value, and it tear up when you apply the forces at the P point. So in that condition, there will be different formula is applicable, and we will going to see that formula in the machine design. So there you can see they used to for the rivet and rivet kind of joint. So in that condition, we have to find out the in that condition we use that formula. So now we move to if there will be any n number of the sharing plane. It's like it's more than two. Then what will happen? You have to divide with respect to that number of n is nothing but the number of your sharing plane. So here it is two. So that's why I have put that n value equal to two. Now we move to the third example, and third example it's based on the combination. It's like sometime you need to put tube and rod kind of structure. In this example, I have put inside the tube there is a solid rod. So it's denoted two is it is noted for the tube, and the one is notation for the rod, and the P force, which is compressive in nature, which is applied at the both end of that, and that is firmly attached. It's not like they are loose in a different manner. If you apply the P force, which is equally distributed for these two material, that tube and rod. So the total force we are applying on this rod is P, and it will apply equally on the two cross that two section, that tube and rod. So the total force is nothing but which is distributed equal to P1 plus P2, nothing but equal to total pressure apply at the end. So there is a compression in both tube and rod, and it is applied, and their end is formed. So whenever you apply the compressive force, the change in length of that both the tube and the rod will be same. So that's why we have taken change in length for the first. That is nothing but the rod, and change in length of the tube will be remain same. And you are very well known that the pressure formula is nothing but pressure stress is which is denoted by stress into pressure force divided by area. So if you multiply that pressure for stress into A, uh, so it will become rho A, rho 1 and into A1. A1 is the first notation is for the rod. So both these stresses which is applicable in this condition. So this is how this is third example we have covered, and now only thing is remember that the force distribution will be equal, and change in length of this both the cross section apply after tensile and compression will be remain same. Now we move to the now another cross section. In this cross section, what will happen? The only thing is the force which we are applying, which is at the center of that tool rod. The first cross section, the big cross section, which is made up of aluminum, and the second cross section, which is made of the steel. Now these two forces we are applied at the end of at the and the end and the common point of that two rod, and it's a firm from it is fixed from the both side, both end, so it is not moving. When you apply the force in the left direction toward that aluminum rod, what will happen? It will try to push that fixed wall or fixed position. So the equal and opposite reaction, which is move in the opposite direction of that applied forces. So the RA reaction, which will be the opposite direction of the P. And when you try to push this aluminum rod in the left hand direction, so what will happen? Due to that, the right hand side of the wall where we have fixed our steel rod, so it will try to move in this direction. So if it is try to move in this direction, the wall is try to pull in the rightward direction. So just because of that, the reaction at the wall which is moving in the RB direction, that right direction. So in this condition, when you apply the force in the left direction, the reaction which is act in the right hand direction. So RA and RB you can see on the graph, and in this condition, we have seen that total the force which we are going to develop in this cross section, nothing but the combination of that force generated, which is equal to the total force applied on that bar. Uh, you can write in the form of RA plus RB equal to twice of the force which is applied on that aluminum. Now, similar fashion, as we replace the pressure force in, so you have to you can replace in this way as well. So stress into A, which is nothing but the force at RA, and stress at A multiplied by area of that A cross section, which is aluminum. Uh, and in this condition, because it is attached at the center, both rod. So whenever you apply the force at the P point, so it try to compress the aluminum, but the same the amount of the length is going to be decreased in the aluminum as the same amount of the extension which are taking place inside that steel as well. So due to that movement of the center point, the total compression in the aluminum rod, which will be equal to the total extension in your steel rod. So you can write this equation, which is change in length in the steel equal to change in length your aluminum. So you can write in the below form as well. So this is your third example, and only thing is most of time there is only two equation we have to write. One is for the force equation, and second for the change in length equation. So with respect to that two equation, you can find out the required value of that P, or a change in total length of that rod. So now we move to the fifth example. In this example, there is a horizontal rod which is held by three cable. The two cable which are made from the same material, and it hold the same length, but the center cable which hold the length L2, and I have denoted as a 2, and the other two cable which is denoted by the notation 1. So, and the P force, which is act at the center of that rod, and it is I have taken as a P. Now when we try to find out the total pressure, which is holding by that three cable, which will be equal to the total pressure is applied equal to twice of the P1 plus P2. Why it is twice? Because the two cable which is in equal length will hold the equal pressure or equal force in it, and because the length of that L2 is different, just because of that it it sustains a different force. If the free cable will be equal in length, equal in diameter, then you can simply close your eyes and just to follow that in the entire three cable will hold the same force when you apply the pressure on it. So this equation you have first drawn, and now we have known that change in length first cross section equal to change in the second cross section, and this condition only follows only when it is mentioned that after the elongation, the bar horizontal ball will remains the horizontal. Because if it is not remains on the horizontal, then definitely there may be difference in these two end cable, which is elongated in a different fashion. So if the initial condition and the final condition of that rod will remain horizontal, that shows that the total change in length of that both cable, which is at place both end and at the center, will have elongated the same amount. So you can write that the equation is change in length first equal to change in length second. So apart from the first example, the remain all example which is based on the force applied and changing length. So apart from there, that they will not ask any kind of parameter to find out. So you can easily find out with respect to that. And now we move to the composite, where you have given a composite material which is hold the different area with a different model of elasticity, which simply shows a different material. And now you have to find out the equivalent, and they used to call it sometime apparent value, uh, compound bar apparent value, and equivalent modulus. So in this kind, this is the very peculiar, the particular condition. They might ask you sometime, and mostly the till that they were never asked in the your gate examination, but in the practice point of view, this gate academy and your ace academy, they will mostly include this kind of concept. Otherwise, this kind of concept they were never asked in the gate examination. So there might be a chance, but not sure. Here you can find out it's a tensile forces which is apply. This is the sandwich combination of two material, different material, which is applied with the P force is tensile in a tensile fashion. So what will be the equivalent area? So first equivalent area is nothing but the total area, which is A1 plus A2, and now the second the value is modulus of elasticity. So with respect to that, if you want to find out the equivalent modulus of elasticity, which by we can find out with respect to E even plus A2 divided by a total area, which is nothing but the equivalent area of that two. And if once you find out this equivalent area and equivalent modulus of elasticity, you can find out the total change in length of that combination of that two material, which is PL divided by area of equivalent divided by the modulus of elasticity at equivalent condition. So this is how you can find out this change in length for the entire cross section. And in this cross section, you can take that the total change in length for the both cross section is going to be same because it is text on the both end side. You can see the hash line on the both end. So that is something, but the both end are fixed each other, and so it is not allowed to expand in the different it's like it will not allow to deform in a different fashion. Like it has deformed in the same fashion at the end. So total pressure is nothing but the total pressure, the pressure hold by the first material plus the total pressure handled by the second material equal to the total pressure which is applied on the end of that rod. Now we come to the final or application, which is nothing but very common application, nut and bolt, and the long cross in this condition there will be long nut which is placed inside the tube, and the it is they use nut to tight up that bolt, and also it contained two washer at the both end, and in the separation there was a tube. So what will happen once you try to tight up the nut? If you try to tighten that nut, what will happen due to that? Once at the limit will come, after that it will try to compress that tube. So when you try to compress that loop, because the limit of the tube is end, and after that, if you try to tight that, if you apply more torque on that nut, so it will try to compress that tube, and due to the compression, the forces which is try to repel that compression, which is acted on the bolt, and due to that, the nut is suffer in the tensile forces. The tube will be suffer in the compressive forces. Washer definitely going to suffer in the compressive forces, because when you try to compress that tube, or when you reduce the length of that cross section, so in that cross section it try to push that away, and just because of that it create the compressive forces in that. So in this condition, the washer is suffer for the compressive forces, the tube will suffer in the compressive forces, and the nut and bolt both are going to suffer in the tensile forces. So the tensile forces uh, in the bolt will be equal to the compressive forces in the tube. So whenever you apply the amount of force you're going to add after that, once its limit is finished, so whatever amount of force you added into it, the equal amount of force which is going to be for your tube, and you can take that the total stress which were developed at the tube equal to the total stress which is developed at the bolt. And when you uh, when you when you tied that nut, so due to that the amount of the length of that nut is going to change, or bolt is going to change. only most of time there will be no change in the bolt length. Only it's in the bolt length, not in the nut. Sorry. So when you tighten that nut, so in that condition, the bolt is going to get elongated in some small fraction. So that and the remaining the force is minus com, which is like the length of that tube is getting reduced. So if you add these two tube together, so it will give the actual movement of that entire span. So this is how we are finished with this lecture, and the above the below diagram I have already explained to find out the total unloading, the total unloading and total strain which were developed after unloading that diagram. So with respect to that, we have to find out the modulus of elasticity, and with respect to that, you can find out the remaining strain which were developed in that diagram. And in some condition, I have already explained that if it is not given that modulus of elasticity. So what they will do, they will take a 0.2% of generally 0.2% of that extension, and it will draw. They were used to draw a parallel line to the that graph, and with respect to wherever wherever it crossed that line. So at that point, they were used to take as the modulus of elasticity for that particular diagram. So and this is the end of the first lecture and the first module of this SOM. And in the next module, we are going to start with the principal stresses, where you can find out the different kind of stresses which were developed with respect to the applied forces, that x direction, y direction, and we are going to combine these forces, and we are going to see. And this chapter is very much important because most of time this knowledge of the principal stresses is going to use in the different books, and the combination of these two mostly will ask in the gate examination. First, they will take the example from the SOM. From that, you have to find out these principal stresses, and when you find out the principal stresses, you have to apply for the different theories which is called the modern machine design. And with respect to that, you have to find out the final example. So it is very. Let's see what will happen.